Alright, good morning guys. So tomorrow is your test. You're going to need a pencil and your calculator. Ms. Stedman will not be handing out either of the two, so please come prepared. It will be a 2-day test, and I'm going to do 6.1 today, but you can actually wait to do that homework Thursday night. Ms. Stedman, I'm going to have you pass out the Chapter 6 packets. Students, if you guys could start on a homework check and discuss any questions you have. Once you are completely done with the homework check and have your questions answered, you can start on the warm-up. And then, Ms. Stedman, you can interrupt them at one point to see if there are any leftover questions. I usually do that after going over the warm-up. So I will have you just press pause in between each of the pieces of the lesson. So at this point, students can do the homework check, discuss homework, and then start your warm-up. Go ahead and press pause. Alright, so at this point, you should have completed your warm-up. I'm going to start off by going over the warm-up, which is kind of the beginning of the lesson. And then after we're done that, I'll ask if you have any homework questions to go over. At that point, Ms. Stedman will take about 2 or 3 minutes to answer 1 or 2 homework questions. If there's time at the end of class, we can come back to homework questions again. But I want to make sure we have enough time for the notes. So starting off, your warm-up here. It says to just graph 3 functions whose derivative is 2. So if you think about that, your functions would have to be any kind of line with whatever intercept you want to pick. So as long as the slope is 2, so I'll do one line pretty far up here just to have them equally spaced out and not crammed. And obviously you don't need to have the same 3 lines, but I wanted you to see that if I just give you the derivative, it doesn't give you the equation. It actually gives you a bunch of equations that are possible to have that derivative. And then the last one I'll just do over here. And there's actually an infinite number of graphs that you can create that have a derivative of 2. So the second piece was just to integrate 2. So obviously the integration would be antiderivative and then plus c. And that plus c is what creates those 3 graphs. So that was a quick little warm-up. If you have any homework questions, Ms. Stedman, you can take those now. Otherwise, we can keep going. We're going to start on the lesson. So here it says, given the initial condition of y is equal to 5, find the only answer to the problem. So I'm going to actually start off with this piece right here. And the way that I want you to integrate, I don't want you to start off right away. I do want you to multiply dx to the other side of the equation. And then we can put in our integral symbols. And I am doing this a certain way because it's going to follow along with the lesson today. Now, the integral of dy, well, the integral would just have to be the y. Integral of 2, which we just did a second ago, is 2x. And because we don't know what the c value is, we have to write the c. So now you can kind of see why we have y of 0 equals 5. So if y of 0 equals 5, then the y value is 5, the x value is 0, therefore the c value is 5. So the one and only solution to this initial condition, this question, is y is equal to 2x plus 5. So the 2x came from over here, and then I just put in the c value. So this is something called a differential equation, and it's a differential equation with an initial value. So why do we need an initial condition? This is to find the unique solution. The other way you can think of it, it eliminates the plus c. You're essentially solving for the plus c. Give the steps to solve an initial value problem. So step 1, multiply dx on both sides, integrate with plus c, and then we substitute in an initial value, which is also considered a point, to solve for c. And then step 4, rewrite the final equation. That's pretty much what we did, just in order. So as we look over to the left here, where have you seen something like this before? I'm actually going to kind of hold off on that question. I wanted to discuss where you've seen initial conditions. So instead of answering it completely, when have we had initial conditions? You remember when we find final position, we need an initial position plus the displacement. That's one place. And then we also did f of b, a final value. You need an initial value plus the integral from a to b of f prime of t dt. So we've actually seen this in a different form, having to use an initial condition, but we just haven't used it with the plus c. So starting off here, we have some equations, and then you see underneath the derivative. So the derivative of that guy is 2x, and derivative of that guy is 2x, and the constants didn't matter. But when we want to go backwards from y prime to find y, it's a little bit harder because the question then has to be rewritten as dy dx is equal to 2x. And let's review our steps. So step 1 was to multiply both sides by the dx, and you get dy is equal to 2x dx. Then you can integrate. So the integral of dy is y itself. The integral of 2x is x squared plus c. And then here, I'm pretty much stuck. I don't have an initial value, so that's the answer to my differential equation. So here, all I'm going to have you guys do is integrate. We're going to review integrating. I'm starting off with kind of a difficult question. Most people tend to get this problem incorrect. So I'm asking you to integrate this, and I'm going to give you guys a second to talk in your groups to discuss what would you do? How would you do this problem? Is it an easy problem? Is it a substitution problem? Is it a graphing problem? A simplifying problem? So go ahead and talk for about a minute. Ms. Stedman, you can press pause, give them a second to discuss. All right, so as we look at the problem, I am curious, and we can do this just by a thumbs up, how many of you decided to use substitution? Okay. How many of you decided to simplify? How many of you decided to graph with a thumbs up, please? How many of you are still stuck and couldn't figure out a method? Thumbs up, please. Okay, so this one is actually a u problem. The u is your denominator. And let's take a look. The derivative of that would be -1. Solve for dx. And I'm going straight through so that you can see why it works. Right now you might still be confused as to why this is a substitution problem. So coming up here, I have the integral of 2 over u times dx, which is du divided by -1. So there's just a lot of things in the way that are constant. So I'm going to take the 2 and the divided by -1 in front of the integral to get it out of my way. And then you're left with this guy. So that happens to be the integral of 1 over u is ln. So this is really an ln problem. I want to discuss why we had to use substitution. So some of you may have said, well, let's just rewrite it so it's not a quotient anymore, because that's the rule that's in the way. But now you just created a chain rule by doing that. So there's really no way to eliminate the rule, and this isn't a memorized derivative rule, so it has to be a substitution problem. Okay? So I get -2 ln of the absolute value of u plus c, which is -2 ln absolute value of -x plus 1 plus c. Up here it says note the integral of dx. It's just a reminder that is x, and the integral of just dy is just y. Just a reminder for you. All right, so down here now I say solve the differential equation. So this will be a lot easier because we pretty much did the problem already. We're going to multiply the other side by dx. And then because of that, we can integrate both sides. I get y is equal to the integral of 2 over -x plus 1 dx, which we just did a second ago, so I'm not going to go through that process again. It's the same answer as above. So first, I'm just showing you how to move your dx over, and pretty much everything else is the same. We're just doing an integration problem. So now, I'm going to have you in your table groups just review a few integrals. Some of these are a little bit trickier than others, so I just wanted to make sure that you're kind of back in the mode of making sure that you can integrate. Remember, we do simplifying, we do graphing, and we do substitution. That's pretty much the only stuff we can do. I don't want to take too much time for this. I probably need about 10 minutes left over. So Miss Stedman, if you can kind of go ahead and give them some time and then cut them off, maybe 10-15 minutes of class left. Hopefully we're not there yet, so that I can finish up the last set of notes. All right, so let's go over the 4 problems. This guy, I do want you to take this step. Please don't skip it. I know for some of you, you don't really understand why. You can't integrate without that dx or dy. Remember, that's the width of our rectangle. You wouldn't have any rectangles if we didn't have that. So this is a little bit of a more tricky question, because this side on the right, we'd have to use a u substitution for the 5x. That would eliminate the chain rule. We have a chain because of this guy. So du, and I'm actually going to take the derivative, which is 5, divide it on this side and set it equal to dx right away. Therefore, I end up with 4/5 integral of secant squared of u and then du. In terms of canceling any variables, nothing would have canceled. If you need some time or you need to make an extra step right here to substitute physically in the dx, please do that. I know sometimes on the board I do skip that step. So don't forget the front side of your equation. So that would just give me y equals 4/5 integral of secant squared would be tangent of u. U happens to be 5x. I'm going to put that back in, and then plus c. All right? This one, dy is equal to 2 over 1 plus x squared dx. Integrate. Integral of this side is y. That would be 2 integral of 1 over 1 plus x squared dx. And that's just a reminder that that is tangent inverse. So right now, you guys should be checking your papers, making sure you're doing each of these correct. All right, 2 more. I'm going to run through these pretty quickly. I'm putting this one back up here because a lot of you have a hard time even remembering the derivative of a to the u. All right, so integral. This is simply a rule that you have to know. You must know that the integral of a to the x dx is equal to a to the x divided by ln of a. All right, so this would be 4 to the x divided by ln of 4 plus c. And then this guy right here, u is equal to cosine of t, because du over dx is equal to negative sine of t, divided by negative sine of t equals dx. How do I know the substitution is going to work? Because this is what's in the way of my product rule. So now I have that this would cancel with this guy, and I end up with, all right, I probably should have squeezed in a little step right here. I should have done this. My bad. I'm telling you guys to do it, but I forget to do it too. All right. Okay, so this side, I'm going to just have y. This side, I picked up a negative. I canceled the sine of t. Integral of e to the u du. So y is equal to negative e to the u, which is cosine of t, and then plus c. All right, so now we're going to actually deal with finding an exact solution. So to solve for c, you must have an initial condition. So looking at this first guy, I have an initial condition. I really, really, really hope that you guys rewrite these in terms of either function notation or as a point. So this x would be first, y would be second. I get a lot of people not remembering that. Or that y of 1 equals 4, that this is the y value, this is the x value. Alright, so this has to be written as dy dx is equal to 2x. dy is equal to 2x dx. And then we're just going to integrate. So right now you guys can do that on your own. I'll put the answer up here. Go ahead and look up when you're done. So once I integrate, I just need to use my initial value. So the y value is 4. My x value is 1 plus c. So c is equal to 3. So the final solution would be y is equal to x squared plus 3. How do I know that that's correct? First of all, I can take its derivative. And secondly, I can do y of the 1 point that we had, which was 1, and I can guarantee that 1 squared plus 3 gives me the 4. That was the y value. All right? So now we'll do some harder problems. Let's start off with this guy. So stepwise, it looks like you probably know what you're doing. So if you guys could please in your groups try this example problem. If you get this one done, you can move on to the next. Let's see how many I gave you. So go ahead and do examples 2 and 3. And then I'll start up here kind of writing out the answers. So go ahead and look up when you feel like your group is done. Please don't copy the board. I know some of you have a hard time doing the work while the answer's being written up. All right, go ahead and look up if you have example 2 done. The answer is down at the bottom here. Y equals 5/2 sine of 2x plus 1/2. And then you guys should be working on your second one, example 3. Alright, so at this point, I want you to take a look at this problem and I want to verify that substitution isn't needed. Hopefully you notice there's no products, there's no quotients, and there's no chain rules. So I know that U substitution won't be needed. It's actually a pretty easy question. The integral of this is itself. The 2 comes down, e to the x, the integral is itself, and then negative cosine of x, we would do negative, the integral of cosine would be negative sine of x, and then plus c, so you end up with y is equal to e to the x plus sine of x plus c, and then over here, my initial value is y of 0 equals 3. Please remember that's your x and that is your y value. So e to the 0 plus sine of 0. plus c, sine of 0 would be 0. E to the 0 is 1. So we end up with 3 is equal to 2 plus c, so c is equal to 1. Final answer, y is equal to 2e to the x power plus sine of x plus 1. Alright, and then this last guy, the last problem of the day, I believe, I would like for you guys in your groups to really try this one. You can see that we're at a second derivative, so you're actually going to use what you just learned along with this to get to the first derivative, and then you're actually going to have to do another integration using that guy to find the final function. Your first integration you'll use a plus c, but the second one you're going to use a plus d. So it may seem a little confusing right now, but I'm going to ask that you guys try to do the problem in your groups, and then Ms. Sedman, if you could press pause and give me probably about 3 minutes at the end of class to finish up. All right, so to start off, so it looks a little funny, mostly because we don't really use the notation that's written there to do this type of problem, but I want to just keep with it. So when we do this, the integral of that will just be dy. So dy is equal to the integral of 2, which is 2x. The integral of negative 6x is negative 3x squared, and then that plus c you're going to need. So we're going to use the point y prime of 0 is equal to 4. So if you want to, if this is confusing, you can even rewrite this as y prime. So my y prime value is 4. My x value is 0. So I know my c value is 4. Okay? So here, I'm going to do my second integration, and I'm going to say that y prime, which I'm going to go back to the notation of what dy. Let me try and give myself a little more space here. Alright, so instead of writing y prime, I'm going to go back to the notation of dy dx, and then I'm going to write 2x minus 3x squared, and my c value was 4. So you do actually have to solve for your c value before you try to do the second integration. So next piece, I'm going to multiply the other side by dx, and then I'll integrate. And here's where I was talking about that d. So here I'm going to write my y. The integral of 2x is x squared. The integral of negative 3x squared is negative x cubed, and then plus 4x. And then you're not allowed to use c again, because if you write c, then we already know the value is 4, because we found it up here, and we defined it up there. So you have to use a new constant. So that's why I'm choosing d. All right, and then, if you remember, y of 0 equals 1. This is your x, this is your y. So 1 is equal to 0 minus 0 plus 0 plus d. That makes it a lot easier. Your d value is 1. So our final solution to this problem is y is equal to x squared minus x cubed plus 4x plus 1. And if you take its derivative, let's check it. Take the first derivative. We get 2x minus 3x squared plus 4. And then let's take the second derivative. 2 minus 6x, and you'll notice that that matches the original question. All right, so just to sum up what we did today, we used integration to solve differential equations. We call them differential equations because they have a differential. Remember, a differential is those guys. We saw them a lot with related rates. And then we essentially use integration to find the integral, and then we use an initial value to solve for the c value. So you need an initial value if you want to find an actual solution to the question. All right, so that should have been today. Remember your homework, going back to the front board. Tonight is number 1, and we'll see you, I guess, you probably won't have a video from me again until, I believe, Friday the 7th.